Welcome to channel Dr.Caos. I'm going to show you how to create a linked list with multiple nodes in it and how to display it. In the previous tutorial we learned how to create a single node in a linked list. This is the code from the previous tutorial, so nothing has changed. I'm just going to continue manipulating this code in order to insert various nodes in the list. Now before we continue, you should know that this is a little more complicated than you think. Now this thing is simple. You can create a node, a simple node in a linked list, and it's simple. But when it comes to multiple node, you have to use some logic behind it, because you're gonna need various small pointers, okay? And you're gonna need to understand the logic behind it, which is the most complicated part of linked list. But do keep this in mind. If you understand linked list, you can understand doubly linked list, you can understand queue, you can understand stack. You can implement anything with this thing. So it's really important that you pay 100% attention on this particular tutorial. So I'm just gonna continue with the same thing over here. This is actually the fifth time I'm trying to make this tutorial because it's kind of complicated to explain it. So I'm gonna try my best. Hopefully this is the one to go with. So what we're gonna do is first come to our create function, where we actually create our node, right? But since we're gonna create multiple nodes rather than a single one, we're gonna need a loop. Or we can call the same function again and again, which is stupid because that will consume more memory. So let's just create a loop. So first I'm gonna ask the user cout, okay? Enter the amount of nodes required, okay? That's what I'm gonna ask to the user, and save it into a variable n, okay? So I'm gonna declare a variable n, obviously, over here. Okay, so I'm gonna ask the user how many nodes you require for this linked list. So while n, okay, that means till n is alive, basically, keep continuing with this loop. So keep this in mind that the loop starts over here and ends over here. I'm going to obviously reduce n minus minus, so the value of n goes on decreasing, okay? So n minus 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 every time the loops gets executed. So we have covered up the simple part. Now comes the actual complicated part. So I'm just going to take the image over here, right here. This is currently our situation. We have got a node, okay, which is being pointed by the start. I'm going to repeat this as I mentioned in the previous tutorial, that start is a node which never gets manipulated. It is a node through which the entire list is referred to, so you should never mess with the start node, okay? Keep that in mind, never mess with the start node. So then we said that the start, well, basically the nodes next, okay, which this is our node. Nodes next is going to be null. This link is not available. This is just for demonstration purposes, okay? This is nothing. Avoid this for right now. Basically, this is next is pointing to the null, and that's it. That is our node. But now we have got a while loop. So there's going to be multiple nodes created. So there's going to be n amounts of nodes created, who's next going to be null. So there's going to be multiple nodes with null, but no one is linked to each other. So for the linking purposes, we are going to require another pointer, which is going to be the temp pointer. Name it anything. It is recommended that you keep the same name as the one in this tutorial, so you can see what you have done wrong. Okay, it's going to be much simpler. So as I told you before, that start is a node which which should not be manipulated ever, because it is the one which holds the starting address of the list, and basically that's it. That's the only reason that you should not ever touch this. So what I have said over here, if start is basically the null, which is going to be only once at the starting of the list, so the start variable, or sorry, the pointer which is declared as null, it's going to say if start is null, which is going to be on the first time, it's going to say put that node is equal to start. That means the first node right over here is going to be start, okay? That's it. It's that simple. Now what we're going to say is we're going to use a temporary pointer, okay, which actually points again to the start, same place. Okay, so what we are saying that temp and start are currently equal. There are no difference between them. So there is absolutely no difference between these two pointers right now. Alright, so what I'm going to say here, I'm going to bring up the image. Temp is exactly at the same position and acts same as of the start currently. Okay, do keep this in mind, this is just temporarily pointing at the same location. Alright, now we want to create multiple nodes. We want to link them together, and there's going to be a situation where start is no longer going to be null, because again, as I told you, this only happens once you execute the program. So it's going to check whether a node is created, and it's going to check start is equal to null. Then the node that we created, put it as equal to start. But you cannot create multiple nodes and assign all of them to the start, because that will make absolutely no sense at all. So we're going to need an else part for this. And what if the start is not equal to null? What if the list is not empty, right? Because if start is equal to null, what we are saying, the list is actually empty, right? So in this situation, what we are saying that the list is not empty, and this is a new node that we have just created that we would like to put it into the list. So what I'm going to do is say the temps next, which is going to be exactly the same as the start one. Okay, temps next is equal to the node that we're going to create. Alright, so if this part is not going to be executed, because obviously start is not equal to null, alright, so else is going to be executed. It's going to say temps next is the node that we just created, the second node that we created. So this thing, this linking is absolutely broken down. Wait a second. Alright, I'm going to erase this, and we're going to also erase this linking. Alright, because temp, which is this thing over here, alright, is saying his next is this thing. Alright, so I'm just gonna take my painting tool. I'm saying that his next means node's next is the new node. Okay, so temp is actually pointing to the node. This will point to this, so there's some kind of linking. So this would be linked to this, right? So this thing is always going to be linked to this. We have achieved a linking over here. Temps next is equal to node. Basically what I'm saying, if the second time means when the loop has already executed once, the first time this part would be executed, right? Because start is going to be equal to null. But the second time the loop is executed, a new node is created, correct? The second node, and we are saying that the temps next, which is exactly the same as the start, is going to be the node. So this thing, which is the temps next, obviously this is the next node over here. So temps next is equal to the node. So we have got some kind of linking between them. So if I kind of erase everything over here, alright, I'm just gonna try to erase everything. Okay, there's no kind of, to avoid complication, alright. Temp, again, I'm gonna take my writing tool over here. Temp, who is exactly the same position as of the start, is going to say that his next means his next right over here, this thing is actually going to point to the node that we just created. Okay, so this linking, which is cancelled over here, is actually going to be achieved. Alright, so we achieved a linking. Now in the situation, we want to bring the temp right over here. Why? Because when the next loop is executed, temps next would be the next node, right? So if I bring the temp over here, correct, everything is going to be for the next node. So temps next is going to point to the third node, which is this one, right? So that's the reason we need temp on the next node. So we can achieve that by typing right over here, temp is equal to node, which is basically going to bring our temp, which is was at exactly the same position as the start one, to the new position. These two statements actually complicate everything. If you kind of take a piece of paper and try to draw it and understand it, you will understand there's absolutely no other way to do it. I can recap this again at the ending of the tutorial, and I will do that, but it's kind of complicated if you don't practice this a little bit. At the first time, even I couldn't do it, but it takes time, basically. You need to understand the logic behind it, as I told you before. There's nothing else, it's just pure logic. We have just added 3 or 4 more statements, and it changes the complete logic behind it. Alright, so I will recap that if you didn't understand it at the ending of the tutorial. But now is the time to learn how to display these, which is much more simpler than this. But this part is done, and I will recap this, don't worry about that. So to display it, we need a display function, obviously, and it's quite simple. Again, we're going to need a pointer called as temp. Alright, which again that's the only reason I didn't declare it globally, because temp is basically used again and again in various functions for different purposes. Okay, make temp is equal to start means temp and start are at the exactly same position. And what we're going to do here is say, let's say that while, okay, temp of next means temps who is pointing to the next node, temp of next, correct, is not equal to null, or make it temp is not equal to null. Temp is not equal to null. Alright, basically print the data. Cout node data, or temp data, actually temp of data, and last one, yeah, that's basically it. And then temp is equals to temp of next, so it gets incrementing to the next position again and again and again. And to call the display function, I'm going to explain this in a minute. Run it. So again, it asks us for the amount of nodes. I want to say 3. The node is 3, 2, 1. There you go, 3, 2, 1. I'm actually going to add some spacing in between them so we can understand it. Alright, now if I run it, I require, let's say, let's bring it down first, 5, 4, 3, 2, 1, 0. There you go, 4, 3, 2, 1, 0. And the last one, again, pointing to the null, is the end of the list. Now, the display function, I'm going to explain this really simply. I'm going to bring up the image, clear every crap out of it, and explain this. It's quite simple. So again, I'm gonna just draw stuff over here. This is actually our start, right? Take a color right here. This is our start, and we are saying that basically over here, temp is equal to start means temp is at the exactly same position as our start. Okay, so temp in the same place, and we are saying while this is not null, while temp is not null, keep on printing stuff, printing data. So while this is not null, print data and go on incrementing. So if temp is currently at this position, at the next loop it should be over here. So that's why I'm saying temp is equals to temp of next. So that is going to make it come over here, because temp of next is this node. So that's basically it. So it's gonna keep on going ahead and ahead and ahead until it reaches to the null pointer, which is over here. So displaying is not really that difficult. The difficult part is creating multiple nodes, which I would like to recap it right now. So again, we ask the user how many nodes you require and store it into the variable n. we took a loop which says while n is not equal to 0, which is basically the same as this, create a new node who will point to the null pointer. Okay, every time a node is created, it will point to the null pointer and the user will enter data for it. Then we have got that sorted. Now the next step would be if start is equal to null, which at the first time, as I told you before a million times, is always null. Okay, if that is so, that means the list is empty, so assign the node I just created, okay, into the start. So there we have got a starting point. Okay, we have got a header. Then we took another temporary variable which is pointing to the exactly the same location as of the start, for the reason of adding more nodes in it. So this is simple enough. Now we come to the difficult part. Let's say we are saying that once the loop is executed again, okay, because the else part would not be executed when the if part is executed, so the loop will be executed a second time. Then it's gonna check first it's gonna create a node, enter the data in it, and point it to the null. Okay, so there's a new node created, and it's saying is start is equal to null, but it is not. That means there's already a temp pointer assigned. Alright, so it's assumed that this is already done because the start is equal to the node. Start is equal to the node that we just created in the previous loop. Then we say that temps of next means temporary pointer, which is exactly the same position as the start. His next is going to be the node that we just created on the second loop. Alright, so that node would be the temp, and that is expressed in the next statement, and that is basically it. And this goes on again and again until the n is not equal to 0, and that's basically it. And then we just display it using a display function. It is a little complicated, but again, it's just this statement that you need to try it on a piece of paper, try kind of drawing it, try temps of next and all that, and you'll probably understand it. It's really not that difficult, but it requires a lot of logical implementation, and that's what linked list really is. It's difficult to explain, but it is not difficult to understand it. And once you get with logic, and you can do absolutely anything, implement absolutely anything with it, queues, stack, whatever you want to do, even doubly linked list, because not many things changes with, as you can plainly see, we just added a few statements, like 4 or 5 statements, and things change a lot. So anyway, this has been the channel Dr.Caos. I hope you like this video. Rate, comment, subscribe. Thank you very much.